All right, so in ES6, every regular expression instance has a Unicode getter that returns true or false depending on whether a new flag, the U flag, which stands for Unicode, has been enabled for that regular expression or not. And that's pretty much what this presentation will be about. Now, a fun fact about the title of this presentation, RegExp.prototype.unicode, you shouldn't ever run this code as it is. So even if you're trying to feature detect for this new feature, if the browser supports it or not, you shouldn't use this code, because technically it should throw an error. You see, Unicode is a getter that is defined on a prototype, but the getter checks if it's being called on a regular expression instance. And RegExp.prototype itself is not a regular expression instance. So just a quick fun fact. Anyway, before we get started, let's just make sure we're all on the same page when it comes to Unicode. So I'm just going to throw some terminology at you. It will be a couple of terms that I will be using throughout the rest of this presentation. So let's get started. So the easiest way to think of Unicode is kind of like a database that maps any symbol that you can think of to a unique name for that symbol and a unique canonical code point, which is a number for that symbol. So for example, you have the Latin capital letter A, which has the code point U plus 0041. And then the Latin small letter a, which is a completely different symbol, so it gets its own unique name and its own unique code point. Now, this is very useful because it allows you to refer to a specific symbol without having to use the symbol itself. You can just refer to the code point or to the name, and everyone can look it up in the Unicode standard and know exactly which symbol you're talking about. Now, code points are usually formatted the way you see here. So they get the U plus prefix, and then they're followed by a number of hexadecimal digits. And usually they're 0 padded up to at least 4 hexadecimal digits as well. Now, there's a bunch of code points in Unicode. For example, there's also the pile of poo and many other emoji. And really, the code points in Unicode span a very wide range. There's a lot of them. It goes all the way from 0 to 10FFFF. So that's a little over 1.1 million different code points. Now, to keep things a little bit organized, Unicode divides these code points up into 17 so-called planes. And I'm not going to bore you with the details for each of these individual planes, but I think the first one is pretty interesting. It's called the Basic Multilingual Plane, or the BMP. It goes from O to FFFF, and I think it's the most important one because it contains all the most commonly used symbols. So whenever you're writing a text document in English or Spanish or German, you probably won't need any symbols outside of this BMP range. Now, all the other planes combined, they are called the astral planes. So they range from 10,000 to 10FFFF. So actually, the vast majority of the Unicode code point space lies in this astral range. It's like over 95% of all code points are there. But because the BMP contains all the most important ones, a lot of developers tend to forget about all those other code points. And I actually gave a presentation about that last year. It was titled, JavaScript Has a Unicode Problem. And I explained some of the issues involving these astral symbols in JavaScript strings. Now, I'm not going to be able to repeat all those examples and explain how you fix them. If you're interested in that, just check out the presentation I gave last year. The link is right there. And just to give you one small example, for example, if you take a string containing only an astral symbol, like the pile of poo emoji, for instance, it has a length of 2 instead of 1, which may not be what you expect. And this happens because JavaScript exposes astral symbols as 2 separate code units called surrogate halves. So these 2 surrogate halves get combined together into a surrogate pair, and this one pair basically represents a single astral symbol. So this is a little bit confusing. Now, let's talk about regular expressions. So there's a bunch of effects that this new U flag for regular expressions has. And the first that we'll discuss is the impact on syntax. It also kind of changes the meaning of the dot operator. Quantifiers are affected as well. Character classes have new behavior. Character class escapes are changed. The I flag for case insensitivity also gets a new behavior when it's combined with the U flag. Even HTML documents are kind of impacted by the existence of the U flag, believe it or not. And finally, we'll take a look at browser support. So let's get started with the impact the U flag has on syntax. Adding the U flag to a regular expression automatically unlocks a new syntax called Unicode code point escapes. These things start with a backslash followed by U, followed by braces. And between those braces, you can use any number of hexadecimal digits you want to use. Of course, you only need 6 to be able to represent any Unicode code point, so that's plenty. Now, this, again, makes it really easy to refer to any symbol without having to use the symbol itself. You can just refer to the code point instead. And especially if you're creating a huge regular expression that tries to match a lot of different code points or symbols, it can make your regular expression actually more readable. If you want to deal with ranges, you probably don't want to look at all these weird characters in your code, but you just want to see the code points instead. And this makes that really easy. In fact, this Unicode code point escape syntax is automatically available in string literals and template strings as well in ES6, but if you want to use it in a regular expression, you need to use the U flag first. In fact, it may look like you're already able to use these code point escapes even without the U flag, but that's not really what's going on. So for example, the code here at the bottom, it doesn't throw an error, which might lead you to believe that it actually already works. But it also doesn't quite do what you would expect it to. So in this case, the backslash followed by the U is actually an unnecessary escape sequence for the U character. And then the braces and the numbers wrapped in those braces, that's a quantifier. So instead of matching the code point U plus 1, 2, 3, 4, you're basically saying match the letter U repeated 1, 2, 3, 4 times. So that's why you need to explicitly opt in by using the U flag for your regular expression if you want to use this feature. And this is also a good reason to not blindly go through your existing source code and just blindly add the U flag to your existing regular expressions, because you might end up accidentally changing their meaning this way. Now, to avoid this kind of ambiguity in the future, the U flag prevents you from using unneeded escapes. For example, the A character doesn't have any special meaning in regular expressions, so there's no reason why you would want to escape it using a backslash. And if you enable the U flag for your regular expression, this will actually throw an error. So this is JavaScript's way of warning you, hey, you're doing something weird here. So really, you can think of the U flag as kind of like a strict mode for regular expressions specifically. I think you should use it for any new regular expression that you create from now on. But at the same time, you shouldn't blindly go back through your old source code and just add the U flag to all your old regular expressions without thinking about what you're doing. Because once again, you might accidentally change their meaning in a very subtle way and possibly break your code. Now, let's talk about the impact on the dot operator. Now, without the U flag, dot matches any BMP symbol without line terminators. So if you use a.b in a regular expression, and it won't match the tetragram for sender symbol, for example, just because that's an astral symbol, and as far as JavaScript is concerned, that astral symbol consists of those two surrogate halves, and it treats each of those halves as an individual character. So this is a bit surprising, but all you need to do to just work around this behavior is just enable the U flag in ES6, and that automatically makes the dot operator work the way you would expect it to work in the first place. Another thing that is affected is quantifiers. Quantifiers are things like the asterisk, the plus sign, the question mark, and numbers wrapped in braces. They basically indicate how many times you want to repeat the previous part of the regular expression. So in this example, we're matching two consecutive A symbols, and this works as expected. But if you try to do exactly the same thing using an astral symbol instead, it won't actually work. The result is now false instead of true. And that is because without the U flag, if a quantifier follows an astral symbol, it only applies to the low surrogate of that symbol. As far as JavaScript is concerned, this is what that regular expression looks like. So you have this astral symbol represented by a surrogate pair, and then this way it's easy to see that the quantifier simply applies to only the last part of the surrogate pair, not to the surrogate pair as a whole. So again, this is probably not what you want or what you would expect. But it's really easy to fix this. All you need to do is just apply the new U flag. And this way, quantifiers apply to whole symbols, even for astral symbols. So it's the only way to make sure that JavaScript treats all code points equally. I believe that's part of the code of conduct at JSConf, so you're basically legally obliged to use the U flag from now on. Now, anyway, another thing that's different is character classes. Without the U flag, any given character class can only match a BMP symbol. So things like B, C, D work as expected. They match either B or C or D. However, if you try to add an astral symbol to that character class, the JavaScript engine once again treats it as two separate characters, one for each half of the surrogate pair. And because of that, the tetragram for center symbol here is not matched, although it's part of the regular expression at the top. So this, again, is a little bit confusing, I think. So as far as JavaScript is concerned, this is what that regular expression looks like. The character class contains not 3, but 4 characters. And that is why the result is false instead of true. Now, all you need to do to fix it, well, you guessed it, all you need to do is just add the U flag to the regular expression, and that magically makes it work the way you expect it to. You can now use whole astral symbols in character classes. Now, this also means that whole astral symbols can be used in character class ranges, and everything will still work the way you would expect it to as long as the U flag is set. So in this case, I'm trying to create a range from the pile of poo character all the way to the dizzy symbol. So I want to match pile of poo, the flexed biceps, and the dizzy symbol. And this actually works the way I would expect it to. However, if you omit the U flag, if you were to try this in ES5, you would get an error. The regular expression would throw, and it would say, the range is out of order in the character class. And that happens, again, because of the same behavior, basically. As far as JavaScript is concerned, this is what that regular expression looks like. You're creating a range between 2 astral symbols. Each of those is represented by a surrogate pair. And now JavaScript tries to create a range between the last surrogate for the first character and the first surrogate for the second one, which is not the range you wanted to create in the first place. And because the first code point is a greater number than the second one, this also throws an error. So once again, just use the U flag, and all these problems go away automatically. Now, the U flag also affects negated character classes. So for example, caret A in a character class matches any BMP symbol except for A. But it won't match astral symbols because, again, JavaScript considers those to be 2 separate characters, 2 surrogate halves. But with the U flag enabled, the very same regular expression now matches the much bigger set of all Unicode code points, all Unicode symbols, except for A. Now, character class escapes are impacted as well. And these are things like backslash lowercase d, which matches any digit from 0 to 9. You also have backslash uppercase d, which matches the inverse set, so anything that is not a digit from 0 to 9. There's things like white space characters, which you can match using backslash s, or non-white space characters, which you can use backslash capital letter S for. And then there's backslash W, which stands for a word character, which is apparently defined as any character from A to Z in lowercase or uppercase, underscore, or a digit from 0 to 9. Now, the U flag affects the meaning of these character class escapes with an uppercase. So backslash D, backslash S, and backslash W. Without the U flag, these match any BMP symbol that are not matched by their lowercase counterparts. So for example, backslash capital letter S matches any non-white space symbol. So it would match the character A, for example, but it wouldn't match an astral symbol like the tetragram for tetragram for center. And that is because, once again, those are considered to be 2 separate characters in JavaScript. This is probably not what you want. Now, with the U flag enabled, backslash uppercase letter D, S, and W, they match astral symbols too, which makes a lot more sense. Now, it's important to note that the inverse counterparts, so the lowercase d, s, and w, they are not affected at all by the U flag. There was, in fact, a proposal on ESDiscuss to change their meaning and to make them more Unicode-aware. For example, backslash d could match many more digits in different scripts, not just those from 0 to 9 in Arabic numbers, but in other scripts as well. But this proposal was rejected in favor of a bigger proposal that I'll talk about in a second. Now, there's another gotcha with this. So there's this thing called case folding, which is essentially the act of converting uppercase Unicode symbols into their lowercase form. And this is not just for letters from A to Z, because that's pretty simple, but you actually need to be aware of different scripts, different languages, and the Unicode standard defines all these mappings for all those different code points. Now, when both the I flag for case insensitivity and the U flag for Unicode are enabled, from the same regular expression, all the symbols are implicitly case folded immediately before being compared. And this might lead to surprising results every now and then. So for example, the regular expression where you match the range from A to Z in lowercase, you can then enable case insensitivity using the I flag. Well, if you now enable the U flag as well, then suddenly you will also match the code point 017F because it canonicalizes to the capital letter S according to Unicode case folding. The same thing goes for the capital letter K and the code point 212A. So this is another one of those things you need to watch out for, and it's another reason not to just blindly add the U flag to your existing regular expressions, because you might change their meaning this way. Now, the case folding logic that I mentioned applies to the symbols in the regular expression pattern as well as the symbols in the string to be matched. So it goes both ways. And in general, that's pretty useful behavior, but in some cases, it can get really, really confusing. So for example, by default, backslash uppercase the letter W matches anything that is not matched by backslash lowercase w. It matches any non-word character. But when both the I and the U flag are enabled, the new Unicode-aware case folding logic kicks in, which means that essentially, well, backslash capital letter W, which is supposed to match non-word characters, now matches the capital letter K and S, which is kind of weird, right? It's probably not what you would expect. So this is another thing to watch out for when you're using the U flag, and another reason not to just blindly add it to all your existing regular expressions. Make sure you're not using backslash uppercase letter W first. Now, believe it or not, but the existence of the U flag also has its effect on HTML documents. The pattern attribute for input or text area elements allows you to specify a regular expression to validate the user's input against. And the browser then provides you with styling and scripting hooks to make stuff happen based on the validity of that input. Now, the U flag is always enabled for regular expressions compiled through the HTML pattern attribute according to the specification. This means if you do things like a.w, if you use that as a pattern, the dot operator will match astral symbols as well, just as we discussed before. Now, what about browser and engine support for this new Unicode features? Well, Microsoft Edge is the only stable browser that ships with an implementation of it at the moment. They support it in their Chakra engine, but they haven't yet enabled the HTML pattern flag yet. However, I found a bug on that, so I can only assume that they're working on it. There's also an experimental V8 implementation available. It's hidden behind the flag, but you can play around with it if you want to. There's still a few very minor bugs that need to be worked out, but we're working on it. So what about all those other browsers? It would be a shame if we weren't able to use the U flag today, wouldn't it? Well, that's why I created this transpiler called regexpu. It basically rewrites ES6 regular expressions using the U flag into equivalent ECMAScript 5 compatible code that works today. So this enables you to start using the U flag today in a backwards compatible way. And you may actually have noticed that the Babel and Google Tracer transpilers, they both support the U flag as well. If you use a regular expression literal with the U flag, they will automatically translate it into an ES5 compatible equivalent regular expression. And that's because these both use regexpu as a dependency. So the good news is if you're already using one of these transpilers as part of your build process, you don't really have to do anything. You can just start using the U flag today. Now, just to quickly give you an idea of how regexpu works internally, so the first step that I take is we need to parse some JavaScript code, right? The user has an ES6 file, some source code. We need to parse that into an abstract syntax tree. I decided to use the Esprima parser for this, but you could use any other parser as long as it has the same as abstract syntax tree format. Then I look for regular expression literals within that AST that have the U flag enabled. Once I found such a regular expression, I parse the regular expression itself using another parser, which is RegJS parser, and that creates a regular expression abstract syntax tree. RegJS parser was originally an ECMAScript 5 compatible regular expression parser, but of course for this project I needed to support ECMAScript 6 features as well, like the U flag and all those new things that I talked about. So I started contributing, and together we made it happen, and that's why I can now just use it in regexpu. Finally, we rewrite each regular expression without the U flag so that it's equivalent but compatible with ES5. And I use regenerate for that and node Unicode data, some data packages on NPM. I'll give you an example of this later. Then we update the regular expression abstract syntax tree. Then we transform the regular expression abstract syntax tree back into a regular expression literal. You could use the RegExp.gen project for that. And then finally, we update our original JavaScript abstract syntax tree so that it contains the new regular expression. I use Recast to do this. It makes it really easy. And also, it takes care of transforming the JavaScript abstract syntax tree back into JavaScript code. So that's it. At the end, we started out with ES6 code that uses lots of ES6 features and also the U flag for regular expressions. And at the end, ECMAScript 5 compatible code comes out. Now, for some things, there's still no built-in syntax in ECMAScript 6, even with the U flag. So for example, Unicode provides a lot of data files for categories, scripts, blocks, and properties. But there is no way to access that data directly in regular expressions. So for example, let's say you want to match all the Unicode symbols in the Greek script. One way to do this is to use a third-party library like RegExp. And that would look like this. So you just use the \p syntax, and then between the braces, you can use the name of a property or a category or a script or a block, and regexp will automatically take care of that for you. Note that I'm also passing the character A there. That is a flag that stands for Astral Symbol Support. It's a custom flag that regexp implements. So this makes it really easy to match all Greek symbols. There's only one downside to this, and that is that regexp is a 35 kilobyte runtime dependency. So it may not be the best solution in performance-critical situations. Now there's another way of coming up with a similar result. You could use a build script, and you could use the regenerate library for that, which I talked about earlier. And that would look something like this. So in Node.js, you write a script like that. You require regenerate, and then you use the Node Unicode data modules that basically just contain arrays of Unicode symbols and code points. So that's what I'm doing here. I'm just getting an array containing all the symbols in the Greek scripts according to Unicode version 6.3.0. And then I'm passing that array into regenerate. That gives me a set of characters or a set of code points. And then I turn that into a regular expression, or, well, actually a string that I can use as part of a regular expression literal. And that gives me this result. Again, this is not a regular expression that I would enjoy writing out by hand, let alone testing it or maintaining it. And you may have noticed that I'm actually using an outdated Unicode version here. This is version 6.3.0, but the latest version at the moment is version 8. So imagine having to update this regular expression manually without having this build script of 4 lines. It would be a lot of work. But now that I have this small script, all I need to do is just change the version number, run the script again, and just like that, an up-to-date regular expression comes out. Now, hopefully, in a future version of ECMAScript, there will be built-in support for the \p syntax that Perl already supports, and some other languages as well. And that way, you could just use \p, braces, and then Greek to match all the symbols in the Greek scripts, and then it would just work as long as you use the U flag. The thing is, everyone agrees that this is a very good proposal, and everyone wants to do this. The problem is that someone needs to do the work and write a specification for it. So if you're interested in that, come talk to me afterwards. We'll make it happen. Anyway, the main takeaways here are you should use the U flag whenever you can. You should use it for all the regular expressions you write from now on, I think. And remember, the U flag is to regular expressions as strict mode is to all of JavaScript. Now, you also shouldn't blindly add the U flag to your existing regular expressions, because you might accidentally change their meaning in very subtle ways that might actually break your code. Finally, you should use a transpiler, because this way your ES6 code runs everywhere. And you shouldn't just use a transpiler for these particular features, but for many other features as well, of course. And Babel and Tracer, they both already support transpilation of the U flag, thanks to regexpu. And whenever you need a regular expression based on some Unicode category or a property or a script, you should just write a simple build script that uses regenerate to build it, or use regexp at runtime. Thank you. So yeah, there's a blog post at that URL, which basically details the same things that I talked about during this presentation. Enjoy.